This stayed the same because it was pulled all the way down to the ground. For this equation, we used this formula. The 2 gravity times y max adjusted equals v max squared minus viy squared. For this equation, I plugged into a calculator, like the video said. For this equation, I just used this one over here. Why does it work? Because distance equals velocity divided by time. And then over here, I used the Pythagorean theorem to figure out that velocity. And once again, I used this equation and used the quadratic calculator online. Got these 2 numbers, and this one's where it first crosses the meter. This is the second one where it comes down crossing the meter. This one stayed the same as well because it was pulled all the way down to the ground. For this equation, we used that formula. For this equation, we used the quadratic formula and plugged it into a calculator online and got that as an answer. And then we plugged that time into that equation because distance is equal to velocity over time, and got that as the velocity. And then I used Pythagorean theorem to get this velocity. And then I plugged those using that formula and used the quadratic formula calculator online again to get that.
The Greek Dionysius, the elder of Syracuse, who was looking to develop a new type of weapon, invented the catapult about 400 BCE. It became a key weapon in warfare and remained so up through medieval times. Catapults were used by ancient Greeks, ancient Chinese, and Romans to be able to shoot arrows and darts as well as stones at enemies and soldiers.
The catapult works because when the potential energy stored in a stretched rubber band is converted to kinetic energy, it snaps back to its loose shape, moving the catapult arm and throwing the projectile. This is the graph that uses the average height and range at different percentages to show the expected launch path.